Limiting reactant or limiting reagent problems are just another form of reacting mass calculation. Except that before we can figure out how much product we're going to form in a reaction, we have to actually have a look and see which of our reactants is going to determine that. Let's have a look at this quick example here. If I've got 3 car bodies and 16 tyres, yeah, run with me, I appreciate my artistic skills are very, very limited. How many cars can I make? Well, clearly the answer is 3. I can make 3 cars. I'm going to have 4 tyres left over, but the amount of cars I can make is limited by the fact that I only have 3 car bodies. So in chemical reaction terms, my car bodies are my limiting reactant, my excess reactant are my tyres. I have more tyres than I need. They're going to be left over at the end of the reaction. So let's have a look at a chemical example here. 5 grams of iron, 5 grams of sulfur. How much iron sulfide am I going to make? Well, once again, I always suggest that you set out the information you have in a way that's going to help you figure your way through this problem. So I know that I have 5 grams of iron. Mass isn't actually all that useful, so I'm going to turn that into number of moles, divide it by the molar mass, so that's 55.8, and that comes to 0.0896 moles. I also know that in this reaction we put in 5 grams of sulfur, and number of moles of sulfur therefore works out to be 0.156 moles. Now, iron clearly reacts with sulfur in a 1-to-1 ratio. I didn't have 1 mole of iron, I had 0.0896, so I only need 0.0896 moles of sulfur to carry out this reaction. I've got far more than that, so I can see straight away that sulfur is my excess reactant and iron is my limiting reactant. So I now know, I can carry on my ratio here, that I am going to make 0.0896 moles of iron sulfide. If I multiply that by its molar mass of 87.9, it comes out at 7.87 grams. So 5 grams of iron, 5 grams of sulfur would give me 7.87 grams of iron sulfide, and I'm going to have some sulfur left over. Straightforward. Second example. This one, the ratio is 1-to-2. Let's see how that affects our the way that we carry this out. We're going to work in exactly the same way. So what do I know? I know that I have got, not sure what's happening here, there we go. I know that I have got 2 kilograms of sulfuric acid. I'm not going to bother changing this to grams. I know that if I work in kilograms, my answer is going to come out in kilograms. Okay, so I'm just going to get rid of my units here. So how many moles of this? Well, if we take it at 2 divided by the molar mass of sulfuric acid, which is 98.1, comes out at 0.0204 moles. How much ammonia do I have? Well, I know that I've got 1 kilogram. Divide it by the molar mass of ammonia, which is 17. Remember the big 2, this number here, that's used to balance this equation, is not part of my molar mass. So the molar mass of ammonia, 1 nitrogen, 3 hydrogen, comes to 17, and that is 0.588 moles. So 1-to-2 ratio, how does that work? Well, I think we can see straight away that the limiting reagent here is going to be the sulfuric acid. I've got 0.0204 moles of that. I only need twice as that, so 1-to-2 ratio. I need 0.0408 moles of ammonia to complete this reaction. Clearly I've got far more of that, so the ammonia is in excess and the sulfuric acid is the limiting reagent. So I can see straight away here, now that was a 1-to-2 ratio, but to the ammonium sulfate is a 1-to-1 1 ratio. So how much ammonium sulfate am I going to make? Well, number of moles, 0.0204, multiplied by the molar mass, which is 132.1, and that comes out to 2.69, 2.7, and we were in kilograms, so I need to remember that my units were in kilograms. I've rounded it up to 2.7 because the information given in the question was to 2 significant figures, so it makes sense to run my answer to 2 significant figures. Easy.